Hey guys, welcome back to this new section. In this section, we are going to talk about introduction to SSL. Now, as we are in this architecture diagram, so this architecture diagram says that you are in a browser, in a laptop, or on your mobile, and you're on a coffee shop and you're trying to browse the website called httplibrary.com, and then the the request goes to the server, but then it goes through something called a middleman who is listening to all the conversation. Now, this middleman is basically could be a router log file on this particular end, or it could be the jumping connections from one end to another. It could be another local DNS provider. It could be anyone who is listening to your conversation. They are not wantedly listening, but some people are wantedly listening in this conversation. They just want to get all the data which is coming through. Now, if you're accessing the bookstore server responds with you with a page wherein which you may have to fill in some details about yourself and some payment information like your credit card number. So now you fill that and send it across, and all those information which you put it as part of this form which you are filling as per the server, you're sending it back. And this middleman is capturing all this information. If you've seen our training on the mod AJP, when we were checking the logs, you were seeing some kind of a data is flowing through. So that data is basically what everyone will be hearing, okay, about the server information. It will have your server JVM name, it will have all the information which is required for any third party, which they don't really have to know. So every information will be encrypted, will be in a plain text format, and while it is sending that information or those information. When you enable HTTPS, these steps of communication happens to secure your message which is going through. As you can see the end result, you can see that the junk character comes in instead of the actual values which we saw earlier. Now, firstly, you open a browser and type http://library.com. Server responds with a redirect, as in like it responds, you're not supposed to come to HTTP, you're supposed to come to HTTPS. This is automatic redirection which happens at the server end. Basically, you can configure your website in a way that it doesn't allow HTTP and always redirect people to HTTPS. So the response comes through and the browser then browses this library.com, and then the browser or the mobile app says client hello when it browsing the HTTPS version. That's the first message which goes through the bookstore server. And bookstore server responds with the server hello, and then it also gives something called a public certificate. We will come to that. The server key, which is very important, and the server key is not stored in anywhere else in the world. It should be saved in the server key. So the server key is basically a private key, so that will be stored here. It will also provide the encryption method, and then the server hello, and then pretty much that's the information it's going to give. Now, this public certificate is a certificate will be given by someone who is registered. For example, this bookstore or the library.com is not that big of a people who is known for everyone like Microsoft or Linux, so that they will install that public key here. Okay, so this bookstore, we have a chain of certificates, we'll come to that, but then let's just agree upon something that as of now it will work for us. Is basically your public certificate of this particular whatever the bookstore is giving or providing to the browser will be validated by the laptop or mobile list of trusted certificate. There are two lists of trusted certificate. One is that root trusted and intermediate trusted. You can also have personal trusted, but no one does that. I'll tell you the reason in the few videos down the line. Next, the browser communicates with the client key exchange here, there was a server key exchange happening, and this is clients. I think I got that wrong with the private key. So that's a server key exchange, and this is client key exchange. So this is like they exchange the keys. The client key exchange, and then the cipher specification and certificate verify. So basically, once the certificate is verified, so it's going to send the client certificate and the cipher specification. And the bookstore, again, the server sends the cipher specifications, and through which the encryption would happen. And the cipher specification will be as part of the store server. So the cipher information should be a hard cipher for it to encrypt. And we will talk in detail about that later point of time again. So the reason why it should be hard is that it should not be, the data should not be hacked by anyone, or it should not be easily converted. So that's the reason why there is a default cipher every time it changes to a hard cipher. The only problem or issue is that the more harder you're going to get, the lesser number of browsers are going to support. For example, my Chrome over here is kept up to date. So as I'm using a desktop or laptop, which is always connected to the network, it's always up to date. But then what if someone is using an older version who was not connected to internet for the last two years, and then they suddenly connect to the internet and try to access your website? The cipher which was there 2 years before will not be supported right now. So they will get an error saying that the cipher which the server is providing is not supported by the browser. So this kind of scenario would happen. The lower versions of operating system people are using, some companies are using lower version of operating system. They don't use Windows 11. Some people use Windows 10, Windows 2015 server. Likewise, they will use like low version. In those things, it should be automatically updated. But if the update is disabled, or they don't have like a stable internet connection to keep them updated. So in those situations, you will have some issues over here. Even for the SSL version also, people face issue because right now we are not using SSL itself. We are using TLS. We are using TLS 1.2. Even a lot of e-commerce websites doesn't want to update their server information to TLS 1.2 because there are a lot of browsers which doesn't even support TLS 1.2. So they are still in TLS 1.1 or SSL v3. So that's basically is the status. Okay, so that's the very expensive move. But then at the same time, the lower the version of SSL is going to be, the higher the risk they have on compromising the data which is getting transferred, because there is vulnerability for each version. So TLS 1.2 sounds to be secure at this moment, but then in the later point of time, you will get a 1.3 version, which will have more updates on the existing one, and those vulnerabilities which was reported in 1.2 will be resolved. Likewise, you will get new versions of TLS. Even the TLS is there, we still call this SSL because that's how it began with. So we are sticking with the term, but then it's quite sad that we don't use SSL anymore, use TLS. Now, when all this cipher information, all the server key and client key exchange is completed, now all the data which is going to go over here will be going through a junk value, which cannot be understood by the middleware because the middleman will not have the proper tool to unlock that code. So it's like you're going on a road and you were threatened by a robber to give your home address and home key. So you have two keys, let's say, for example, one key is to lock stuff, another key is to unlock stuff. So you would be giving the locking key. So what he can do with the key is that he'll go and lock everything. But what can unlock that? What that key has locked is the unlock key which you have. So the unlock key is nothing but your private key which stores on your server. So the logic of locking is basically on the unlock key. So every time a browser asks for a key, so you can see that it gives public certificate, that is the locking key. So it will give the locking key, and basically your browser will lock stuff around using the cipher information and all those other informations which it has, which is sent by the store server, and then basically sends the data out there. So who can unlock that data is your private key. So that's why private key will not be shared to anyone. Even to the certifying authority, we will never share private key. Okay, we will only share something called a CSR, a certificate signing request. Anyway, so much information for the first introduction video. I'll see you on the next video, which we will talk more in detail about these action items. Thanks again for your patience. I'll see you on the next one.